In this video, I will be breaking down the Kinematics FRQ answer document for the two FRQs that were picked out. The first one that we're going to start off with is off of the 2015 exam. This is question number 4. Two identical spheres are released from a device at time t equals 0 from the same height h as shown above. Sphere A has no initial velocity and falls straight down. Sphere B is given an initial horizontal velocity of magnitude v0 and travels a horizontal distance d before it reaches the ground. The sphere reaches the ground at the same time, tf, even though sphere B has more distance to cover before landing. Air resistance is negligible. Now this is a 7-point question. Going to skim everything. The dots below represent spheres A and B. Draw a free body diagram showing and labeling the forces, not components, exerted on each sphere at half of the final time. So when they're halfway down, well, not halfway down, but after they've been falling for half of the total time. On the axes below, sketch and label a graph of the horizontal component of the velocity of sphere A and sphere B as a function of time. And then in a clear, coherent paragraph length response, explain why the spheres reach the ground at the same time, even though they travel different distances. Include references to your answers in part A and B. Now that I've skimmed the entire question, I see that this is a paragraph question. Out of 7 points, 5 of those points are down here in the paragraph, which means I should not spend much of my time on the free body diagram or the sketch of the graph. Now, this is off of the 2015 exam. They've changed some of the expectations. Typically, a free body diagram would be about 2 points and a sketch would be about 2 points, but here they're actually going to be 1 point each. So here we have our answer key. For part A, sketching only one force pointing straight down from each sphere and indicating that this force represents the force of gravity. Actually, calling it mg is not the best way to call it. You should reference it as F with a subscript g or capital W for weight. But the important thing here is that both of the forces have to be correct. Both of the free body diagrams have to be correct for you to get full credit. And it's only 1 point for that. For sketching a horizontal line, at 0 velocity for sphere A, so if we remember, sphere A was the one that was dropped, so the horizontal velocity of sphere A was 0 the whole time. And then we also have to have a horizontal velocity for object B, because horizontal velocity is constant. Objects do not accelerate horizontally as they fall. Both of those graphs are 1 point. Possibly why the free body diagram and the sketch were each 1 point was because this is such a basic topic that should have been covered in the first couple weeks of class that they didn't want to assign too many points for it. Now for the paragraph, you need to make 4 distinct points to get the 4 content points, and then you need to have a clear, coherent paragraph length response that correctly answers the question to get the 5th point. The first point is indicating the difference in horizontal motion does not affect the vertical motion of the sphere. So simply stating that horizontal velocity and vertical velocity are independent of one another. Horizontal acceleration is independent of vertical acceleration. So differentiating between horizontal and vertical. Indicating that because both of the spheres start with the same initial velocity, and they have the same initial vertical velocity, and they have the same vertical acceleration, and they fall for the same distance, they would fall for the same time. This could actually be said in one kind of a run-on sentence. You could say something along the lines of, the horizontal motion of the balls does not affect the vertical motion of the balls. Since both balls have the same initial velocity in the vertical direction, and they accelerate at the same rate vertically, and they fall for the same distance vertically, they reach the ground at the same time. So I've made a chain of statements because of this, then this is true, then this is true, then this is true. That leads us to our answer. So that's it for that question. The next question we had was off of the 2016 free response question. This was a 12-point question. A long track inclined at an angle theta to the horizontal has small speed bumps on it. The bumps are evenly spaced a distance d apart as shown in the figure above, the track is actually much longer than shown with over 100 bumps. A cart of mass m is released from rest at the top of the track. A student notices that after reaching the 40th bump, the cart's average speed between successive bumps is no longer increasing, reaching a maximum value v average. This means that the time interval taken to move from one bump to the next becomes constant. Part A, consider the cart's motion between bumps 41 and 44. In the figure below, sketch a graph of the cart's velocity v as a function of time from the moment it reaches bump 41 until the moment it reaches bump 44. Over the same time interval, draw a dashed line at v equals v average. Label this line v average. Suppose the distance between the bumps is increased, but everything else stays the same. Is the maximum speed of the cart now greater than, less than, or the same as it was when the bumps were closer together? Briefly explain your reasoning. With the bumps returned to the original spacing, the track is tilted to a greater ramp angle theta. Is the maximum speed of the cart greater than, less than, or the same as when the ramp angle was smaller? Part D, before deriving an equation for a quantity such as v average, it can be useful to come up with an equation that is intuitively expected to be true. That way, the derivation can be checked later to see if it makes sense physically. A student comes up with the following equation for the cart's maximum average speed. The average speed equals c times force of gravity sine theta divided by d, where c is a positive constant. To test the equation, the student rolls a cart down the long track with speed bumps many times in front of a motion detector. The student varies the mass m of the cart with each trial, but keeps everything else the same. The graph shown below is the student's plot for the data v average as a function of m. Are these data consistent with the student's equation? Yes or no? Briefly explain. Another student suggests that whether or not the data above are consistent with the equation could be incorrect for other reasons. Does the equation make physical sense? Okay, this is a long one. It's a 12-point question, so we're going to break it down. Part A, we have a sketch of a graph with two parts. If I look at the scoring guideline for this, that is going to be actually 4 points total. Part I, having a consistent upward slope in each segment between bumps, so showing that your cart between bumps is going to accelerate. We have this upward slope. And second point is for having the velocity reset abruptly at each bump, so having the bump immediately decrease the velocity very quickly. And for having the same maximum value in each cycle that occurs near the bump. This last point might be the hardest point. It's just taking into account the fact that the question stated that the cart reaches an average speed and does not increase from that average speed. So that means the maxima and minima have to be consistent. So these maximum points have to be the same. Note, this point can be earned for a sinusoidal curve with peaks at the bump times. So if you don't have the sawtooth nature, where it immediately drops down, and instead went with a sine wave, you could earn that third point. Part 2 is just 1 point. It's for drawing a horizontal line for average speed. It needs to be horizontal because you're trying to represent that the average speed is constant. The second part, part B, suppose the distance between the bumps is increased, but everything still stays the same. Is the maximum speed of the cart greater than, less than, or the same as it was when the bumps were together? Correct answer is greater than. No points are earned if the correct answer is selected, so just checking the box earns you nothing. No points are earned if the wrong answer is selected. So if you picked the wrong answer, even though there's no points for picking the right answer, picking the wrong answer immediately invalidates your response. You need to have some statement that there is more time between bumps, and for connecting that the cart has more time or more distance to accelerate between the bumps. So an example statement, the maximum speed is greater because the cart has more space or time to accelerate and build up speed. An alternative explanation uses energy for indicating that the potential energy difference increases due to increased height between successive bumps. For rating that for relating that increase in potential energy to an increase in kinetic energy. So by separating the bumps, there's actually a greater vertical displacement between them. So our cart has a greater change in potential energy, so it will have a greater change in kinetic energy. Part C. With the bumps returned to the original spacing, the track is tilted to a greater angle theta. Is the maximum speed of the cart greater than, less than, or the same as it was when the angle was smaller? Correct answer is greater than. No points are earned if the correct answer is selected, but the explanation is completely incorrect, or there is no explanation. No points are earned if the wrong answer is selected. So again, choosing the wrong box can immediately invalidate your response. So we can indicate that the acceleration would be greater because that angle theta is greater. The component of gravity that is causing acceleration is going to be more in line with the track. So our acceleration is greater, for indicating that the component of the gravitational force increases. You could also go back to the energy explanation. And it's interesting that both Part B and Part C, you could actually use the same energy explanation. It's word for word. The same explanation would work. Part D. We're trying to determine if the data presented are consistent with the student's explanation. So, part DI, the correct answer is no. So, we have a function V average related to the mass. So you need to indicate that average speed is not proportional to m, and you need to connect the equation to the data. This is because the y-intercept of the graph is not 0, but the equation indicates that it should be 0. So the equation does not give us a y-intercept. And while this is a linear relationship, it should have a y-intercept. Also, if we double the mass, we should double the average speed according to the equation, but doubling the mass from 1 to 2 does not double the speed. We go from a speed of about 1.5 to a speed of about 2. So there were 2 points there. If yes is selected, 1 point could be earned. So you could actually earn a correct points, or you could earn some points if you selected the wrong answer. For stating that the average speed looks approximately proportional to m. Then the second part, we need to determine if this equation is physically reasonable. So correct answer no for indicating that the distance dependency is incorrect. For indicating that according to the equation, the greater d leads to a smaller v. So because the distance is in the denominator, the separation between the bumps is in the denominator, that completely invalidates the student's hypothetical equation. Now you'll notice it never asked you to derive an equation, it just gave you an equation and asked you to analyze it. Make sure that in your analysis you directly reference the equation. You don't try to make your own equation. Only derive your own equation if the verb given to you in the question says to derive an equation. This said to briefly explain your reasoning. And that'll do it for this video response on these two Kinematics AP FRQs.